In this lecture at Medical Sciences, we want to discuss about calculating molarity of solutions, which is covered under biochemistry and clinical chemistry. So we want to discuss different formulas used to calculate molarity of solutions and different examples. And as we begin, if you haven't subscribed, it's your first time, please remember to hit the subscription button, like the video, and share to many others. So, want to look at how can we calculate the molarity of solutions. And you can ask yourself, what is a solution? What is a solution? A solution is a homogeneously or a uniformly mixed. It can be a liquid, it can be a solid. So a solution is something that contains homogeneously mixed substances. So if I have a uniformly or a homogeneous mixture, it is the homogeneous mixture. That is what we can call a solution, whereby either you have a solute which is well mixed in a liquid, or what we call a solvent. And a solvent is the one which is always high in amounts, then a solute is smaller in amount. So the substances which are found in a solution are known as solutes, or we can call them analytes, which are always dissolved in a solvent. So that is what we can call a solution. So anything that is uniformly mixed, you have mixture of one or two substances uniformly mixed in a solvent, is what we call a solution. And these solutions, we can calculate them by looking at the number of substances within them. And the formulas we normally look when we are calculating about the number of solutes in these solutions, we use the word mole. We use mole, whereby mole is number of substance or number of substance or solute in a solution. That is what we call a mole. And remember that a mole, one mole of the substance can be equivalent to molecular weight of that substance. Can be equivalent to molecular weight of that substance. So 1 mole. So if you know the molecular weight of a substance, it is the same as 1 mole. So 1 mole is contained in the molecular weight of that substance. That is very important to note. Then this one, so to calculate the number of moles, in a solution is equivalent to mass, and this mass should be in grams. You divide by molecular weight. You divide by molecular weight, also in grams. So this is the formula we can use to calculate the number of moles in a solution. The first thing we have seen that the SI unit, or the standard unit of expressing substances in a solution, is mole, and we have seen that mole is the number of substances or a solute in a solution, which we have seen that 1 mole is the same as molecular weight of that substance. And we have gone ahead to see that to calculate the number of moles in a solution, you get mass of the solute in grams, then you divide by the molecular weight of the solution or of that solute. That is how we can get number of moles, as we shall see in different examples. So after understanding what mole is, now we need to understand molarity, or which we call mole per liter. And molarity is the number of moles in a liter. We're going to see molarity is number of moles of a solute in a liter, in 1 liter of a solution. That is what we call molarity. So molarity is always in a liter or 1,000 mils. Number of moles of solute in 1 liter of a solution. That is what we call molarity, or what you can call mole per liter. And this molarity can be calculated. Molarity, or what we call mole per liter, can be calculated by using the formula saying number of moles of a solute divided by molecular weight. Now here it is divided by the volume of a solution, divided by volume of the solution, and this one should be in liters. That is the formula we can use to calculate molarity of a substance. Number of moles divided by the volume of the solution. Or in terms of normality, another formula we can use, we can say molarity is equal to normality divided by valence, whereby valence is the combining power of an element, then normality is the equivalent weight of a solute in a liter. So we are saying normality is equivalent weight of a substance in 1 liter. So this is the formula we shall also apply in calculating molarity. Normality divided by valence, or we can say number of moles divided by volume of a solution in liter. So after looking at these equations, these are the formulas we have seen, formula number 1, formula number 2, and formula number 3. So we are going to apply this to calculate these examples, then we shall see the exercise. And the example 1 is, if you are asked to calculate the molarity of 2.8 moles of nitric acid in 4 liters of a solution. So you are given volume, you are given moles. So since we have moles, number of moles of nitric acid, and we have even the volume in liter, we are going to see molarity, or what we call mole per liter, is the same as number of moles you divide by volume, and this volume should be in liters, which is already given. So means this is 2.8 moles you divide by volume, which is 4 liters, and the answer will be 0.7 molar, capital M, of nitric acid. So this one becomes the molarity, because we are provided with moles and liter, and we know that molarity is equal to number of moles you divide by volume. So we are able to get 0.7 molar, or you can say 0.7 moles per liter. Then the second example, we are given to calculate the molarity of 4 normal sulfuric acid. And we have seen there is another equation here. another formula, that molarity is equal to normality divided by valence. And we are given normality as 4 normal, and the valence of sulfuric acid is 2. Then normality is given as 4 normal. So from molarity equal to normality divided by valence, we are able to get 4 normal, we divide by 2, and we get our final answer as 2 normal, 2 molar sulfuric acid. We get our final answer as 2 molar sulfuric acid. So therefore, the molarity of sulfuric acid is equal to 2 molar. This one becomes the final answer, because we know that to get molarity, you get normality, you divide by valence, which the valence is the combining power of an element, whereby in sulfuric acid it is 2. So you get 4, you divide by 2, you get your 2 molar as the answer. Then number 3 is asking you to calculate the volume of 2 molar. We require you to calculate the volume of 2 molar hydrochloric acid that can be made from 100 grams of hydrochloric acid. So in this question, before you approach it, you have to know what is given, then you look in your different formulas. So we are given molarity, we are given grams. And when we look at our formulas, I can easily use number of, I am not given number of moles, and they want volume, but I have the molarity. So the first thing to do is to look for the number of moles of hydrochloric acid, so that I can use number of moles, because I'm able to get by using this formula number of moles equaling to mass over molecular weight. So we are going to use that, the first formula, which says number of moles. We are looking for number of moles, which is equal to mass in grams divided by molecular weight of the substance. And the grams are given. Mass is given, should be in grams, and the molecular weight of hydrochloric acid can be calculated, whereby molecular weight of hydrochloric acid is equal to 1. The atomic mass of hydrogen is 1, whereas the atomic mass of chloride is 35.5, and I get 36.5 grams as the molecular weight of hydrochloric acid. So since I have mass as 100 grams, I have molecular weight. To get number of moles is equal to mass, which is 100 grams, you divide by molecular weight, which is 36.5 grams, and you end up getting, if we get 100 divided by 36.5, I'm able to get 2.74 moles of hydrochloric acid. So now we have got the number of moles. So number of moles is that. So since I have number of moles, I have molarity. Molarity is 2.4 molar. So I can easily use the formula saying molarity is equal to number of moles we divide by volume. And this volume we said it should be in liters. And the good thing, I have already molarity. So molarity is 2.4 molar equaling to number of moles, which is 2.74 moles. Then we divide by volume. Then from here I make volume the subject of the formula by cross multiplying, whereby I'm going to get 2.4 molar volume equaling to 2.74. Then I divide both sides by 2.7 molar to make volume the subject of the formula. So I will divide both sides by 2.4. This one goes with this, and I remain with volume equaling to 2.74 divided by 2.4, we get 1.14 liter. So this one becomes the final answer. So the final answer, because they wanted us to calculate the volume, and the volume is 1.14 liters. How? We started by calculating the number of moles since we were provided with grams, and we can easily get the molecular weight. And sometimes, many times in the exam, the molecular weight or the atomic mass of substances in a solute are always provided. So we can always find the molecular weight, then we get the number of moles. After getting the number of moles, we substitute in this formula whereby molarity is equal to the number of moles you divide by volume in liter, and we are able to get that. So the last example, we're asking us how many grams are needed to make 1 liter of a 2 molar hydrochloric acid. So in this question, you have to identify what is given. We are given 1 liter, that is volume. We are given molarity, and they want you to calculate grams. So since I have molarity and I have volume, I can easily use this formula, which says molarity is equal to number of moles divided by volume. Because I have already molarity, I have volume. So from molarity equaling to number of moles divided by volume in liters, molarity we already have it, which is 2.2 molar is equal to number of moles which we don't have. We divide by volume, which is 1 liter. This is over 1. I cross multiply, and on cross multiplying I will get 2 molar times 1 liter is equal to number of moles. Then finally, number of moles of hydrochloric acid is equal to 2 moles. So after obtaining number of moles, and the question wants grams, it means I can easily use the formula number of moles equals mass of a molecular weight, because they want the mass, and I have the number of moles now. So I can use this formula equaling number of moles is equal to mass in grams divided by the molecular weight. So from number of moles equaling to mass in grams divided by the molecular weight of a substance, meaning, and we have number of moles as 2. So we substitute where there is number of moles, we put 2 moles of hydrochloric acid is equal to the mass which we want in grams, we divide by the molecular weight of hydrochloric acid. And the molecular weight of hydrochloric acid is equal to hydrogen is 1 plus the molecular mass of chloride, which is 35.5. You get 36.5 grams. So the molecular weight of hydrochloric acid is 36.5. So we come and put it here. Then we cross multiply. We shall get 2 moles times 36.5 equaling to mass, which we want in grams. And finally, mass in mass of hydrochloric acid is going to be 36.5 times 2, and this one shall give us 73 grams of hydrochloric acid. So this one becomes the final, because they want how many grams are needed. So this is how you can get it. So you have to know how to apply these 3 formulas depending on what is given. You have to first assess the question, then you know what do we want, and what do I have at hand, so that I can apply an appropriate formula to calculate that particular, or to approach the question so that you can easily answer. So this is what we can discuss. I can end by giving you an exercise in this, whereby the exercise is saying that how many grams of calcium chloride, this is exercise, how many grams of calcium chloride, how many grams of calcium chloride are contained in 225 mils, that is the volume, 2 mils of a 0.035 molar calcium chloride. So this is the exercise I want you to do, and you can share your answers in the under comment section so that we can harmonize. So I want you to calculate how many grams of calcium chloride are contained in 225 mils of a 0.35 molar calcium chloride solution. Thank you so much for learning with us. Please remember to subscribe, like the video, and share to others. That is the gift you can give us so that we can continue to serve the world. Thank you so much.